Distribution Requirements Planning, DRP, is a time-phased planning methodology used to manage inventory replenishment and distribution activities across a network of distribution centers, warehouses, and stocking locations. DRP extends demand management principles into the distribution environment by translating forecasted and actual customer demand into planned replenishment requirements. The process helps organizations maintain product availability while minimizing inventory investment and logistics costs. DRP serves as a critical link between demand planning, logistics execution, and manufacturing operations because distribution requirements generated by warehouses and distribution centers become inputs for production and procurement planning. Through systematic replenishment planning, DRP improves visibility, coordination, and responsiveness throughout the supply chain. One of the primary functions of DRP is managing near-term supply and demand at distribution centers through the use of planned orders and released orders. Planned orders represent anticipated replenishment requirements generated by the DRP system based on projected inventory balances, forecasts, and customer demand. Released orders are planned orders that have been authorized for execution and communicated to suppliers, manufacturing facilities, or upstream distribution locations. This structured approach ensures that replenishment activities occur at the appropriate time and quantity. By continuously evaluating projected inventory levels against anticipated demand, DRP helps prevent stockouts, reduce excess inventory, and maintain targeted customer service levels throughout the distribution network. DRP also plays an important role in validating strategic and tactical planning processes. A logistics resource requirements plan uses DRP outputs to determine whether sufficient transportation, warehousing, labor, equipment, and inventory resources exist to support the demand plan developed during sales and operations planning, S&OP. Similarly, logistics capacity plans use DRP information to verify that transportation networks, storage facilities, and distribution resources can support master schedules and operational plans. This validation process ensures that demand forecasts are feasible from a logistics perspective. When capacity constraints or resource shortages are identified, organizations can adjust plans proactively before disruptions occur, improving coordination between planning and execution activities. An important capability of DRP is determining minimum and maximum inventory levels while simultaneously evaluating logistics capacity requirements. Minimum inventory levels establish the lowest acceptable stock quantity needed to protect customer service and accommodate demand variability. Maximum inventory levels prevent excessive investment in inventory and reduce storage costs. DRP calculates replenishment timing and quantities by considering forecast demand, lead times, safety stock requirements, order cycles, and transportation constraints. The resulting inventory policies help balance service and cost objectives. Because inventory levels directly affect transportation volumes, warehouse utilization, labor requirements, and equipment needs, DRP also supports effective capacity planning throughout the logistics network. The DRP process relies on several key inputs to generate replenishment recommendations and inventory projections. Typical inputs include demand forecasts, customer orders, beginning inventory balances, scheduled receipts, lead times, safety stock requirements, lot sizing rules, transportation constraints, and inventory policies. Using these inputs, the DRP system calculates projected available balances, net requirements, planned order receipts, and planned order releases for each time period. Outputs from the process provide visibility into future inventory positions and replenishment needs. These outputs support decision-making related to procurement, production scheduling, transportation planning, warehouse operations, and customer service management while ensuring alignment between demand expectations and supply capabilities. The DRP planning grid is the primary analytical tool used to organize and calculate replenishment requirements over time. Similar in structure to material requirements planning calculations, the DRP grid contains rows for forecast demand, customer orders, projected inventory balances, scheduled receipts, net requirements, planned order receipts, and planned order releases. The process begins by projecting inventory balances forward through successive planning periods. When projected inventory falls below required levels, net requirements are identified and replenishment orders are generated. Lead times are then applied to determine release dates. This systematic calculation process enables organizations to anticipate shortages, coordinate replenishment activities, and maintain sufficient inventory levels while minimizing unnecessary stock accumulation. Several inventory ordering policies can be applied within DRP systems depending on product characteristics, demand patterns, and business objectives. Common policies include fixed order quantity, fixed order interval, lot-for-lot replenishment, economic order quantity, and minimum-maximum inventory methods. Lot-for-lot ordering replenishes only the exact quantity needed, minimizing inventory levels but increasing order frequency. Fixed quantity policies provide consistency but may create excess inventory during low demand periods. Minimum-maximum approaches trigger replenishment when inventory falls below predetermined thresholds. Selecting the appropriate ordering policy is critical because it influences inventory investment, transportation efficiency, warehouse utilization, and service performance. Effective DRP implementation combines suitable ordering policies with accurate demand information to optimize distribution network performance.